Perms and cons. Combination, part 1. 12 face cards are removed from a deck of 52 cards. From the face cards, 3 cards are dealt. Determine the number of distinct 3-card hands that are possible, which include A, no restriction. Why did I highlight that? You don't need to highlight that. Anyways, so from the face cards, there are 12 and 3 cards are being dealt. So meaning if there isn't any restrictions, we can say 12, choose 3. Easy. B, 3 kings. So I want all 3 kings, but how many kings are in there in the face cards? There's just 4. So 4 kings. And I want all the 3 to be kings. Okay. How about C? 1 queen and 2 kings. So there are 4 queens. Within these 4 queens, I want to choose one of them. And the remaining 4 kings, I want 2. So this is queens and kings. And when I add up the 1 and 2, I should get a 3. Because that's the total number of me choosing, right? Okay. D. Only 1 jack. So we have 4 jacks, and I just want 1 of them, which means that the remaining 8 of them would be any cards. So the 4 is jacks, and the 8 is kings and queens. So yellow that I highlighted, they should add up to 3. So now your question is, hey, can I use the same trick as, with the N? Yes. With the pink, take a look. 4 plus 8 is 12. 12 face cards. Then a follow-up question you might ask, how about B and C? I don't see any, I don't see that I can add up to 12. Well, you can. If you add this in, it will add up to 12. This is jack. None, no jacks. Because for part C, we don't want any jacks. And this would be a 1. So that's why we don't need to add it in. Same thing for the kings. We can times it by 8 and 0. And the 8 in here, they're queens and jacks. Once again, this is a 1, so we don't need to add in anything. It's not necessary. Okay? So 4 and 8 add up to 12. 4 plus 4 plus 4 is 12. And then 3 plus 0 is 3. 1 plus 2 plus 0 is a 3. And we're done. Here's the yo-yo, and have fun.